All right, this video we're going to get into complex numbers here, so we're moving on to section 2.4. Basically, kind of main concept here, complex numbers, this is where we have a negative in the square root. Number 2, I'm not going to do this one. I want you guys to do that one on your own. We'll go over in class tomorrow, but I want you to use the quadratic formula for this. When you use the quadratic formula for this, you should get a negative in the square root, and now we're just going to kind of go over what do we do with the negative. And basically with the negative, we pull it out and we replace it with I. And we're going to go over what I equals. So let's do the first one together because that's kind of our definition, gives us our definition of what I is. Now number 1, I wouldn't use quadratic formula because I don't have an x value. I could easily just get x squared by itself by subtracting 1 both sides. So x squared would have to equal -1. Now when I take the square root, normally we just said, all right, there's no solution. So what this means is this graph is not going to hit the x-axis because you do not get real zeros for the solution for x, but we're going to get complex zeros or complex numbers for our solution for x. Now when I do this, I get x, and I get plus or minus the square root of -1. Okay, that's our definition. So I put up here, our definition is I basically replaces the square root of -1. Now we can't graph that, but now we can list this as our two answers are plus or minus I. Okay? So see if you can do number 2, use quadratic formula, and you can pull the negative out, and it'll be replaced with this right here, the I. Real quick, I'll just say, if you did graph this, x squared plus 1, you know the graph. That's a parabola that just, its vertex shifts up 1 unit, and it looks like this. Now this makes sense. It does not hit the x-axis at all. Because when you set it equal to 0, you get imaginary or complex solutions. And that you cannot graph on the real number line or the coordinate plane. So to kind of sum it up, complex numbers, they're usually written in this form. I'll say a plus bi. A is, we'll say, the real part, and b is the imaginary part. Now the one that we did, there actually was no real part. So for this, it's almost like saying A was 0, and in this case, since it's just I, we say B is 1. Alright, so if we solve for any equations and we get complex solutions, that means there's a negative in the square root, and that you cannot graph on the x-axis. It's not going to hit it. Alright, so let's see here. Here we're going to go over some basic operations with complex numbers. And a lot of this is real easy. If we add, subtract, or multiply, which is what you see we're going to do next, we're really going to treat the I as if it's just a variable. So if I add or subtract, I can only add the like terms. So I know if I added, see I have both these binomials in parentheses, it's almost like I'm distributing 1. So if I distribute 1 to that 1 minus 6i, it stays the same. So I really can get rid of the parentheses. So it's just 4 plus 7i plus 1 minus 6i. Well, let's see here. If I combine the 4 and the 1, that gives me 5. So I'm done with that. Positive 7i minus 6i gives me positive i. So it's just 5 plus I. And I can't combine these because these are not like terms. So that's it. Okay, if I do number 2, 2 is a combination of adding and subtracting. Again, if I'm adding, it's almost like I'm distributing 1. But here, if I subtract, I'm distributing -1. So that's going to be different there. So I'm still going to have 3 plus 2i. Still going to have plus 4 minus I. But what's different here is I'm distributing -1 to the 7, so it's minus 7. Distribute -1 to this plus I, that becomes minus I. That's the only thing that's different. Now I got rid of the parentheses, so I can combine like terms. So let's see here, I have 3 plus 4 is 7. 7 minus 7, these go away. So there's no real part. And then let's see here, I have 2i minus I, which is I minus I. These all go away. So I just end up with 0. So the reason why I wanted to show you 2 is you could add or subtract a whole bunch of complex numbers, and we end up with a real number. We end up with 0. There's no I, all the i's went away. Alright, let's go to multiplying. Multiplying again, we're going to use the same rules than we multiplied if we just had x or we just had y. So number 3 is real easy. You just distribute the 4. So 4 times -2 is -8. 4 times the 3i is plus 12i. And that's it. That's your answer. Number 4, we're going to have to go back to good old FOIL method where you just distribute twice. So let's see here. 2 times that 4 is 8. 2 times the 3i is plus 6i. Negative I times 4 is minus 4i. And negative I times 3i, this is where it gets a little tricky. This is going to be negative 3i squared. All right. Now, the one thing I actually did, I forgot to mention, I'm going to scroll up right here. Where I had this I, where I had if I equals the square root of negative 1, I squared, we're going to see this a lot. We like whenever we have I squared. Think of it, if you square this, it's just going to give us negative 1. So when you have I squared, just change the sign of what's in front of it. And that's what we're going to do for this, the one that we foiled. All right, so let's look here. I'm going to have 8. Well, this I can combine. 6i minus 4i is 2i. Now, this is like saying negative 3 times negative 1. So that's like saying plus 3. So let's just put plus 3. So we get rid of this. And then I can add the 8 and the 3. So we get 11 plus 2i. So that's our answer for 5. Okay, let me erase. I'm going to erase. So make sure you have this. I'm going to erase some of this work. Oops. I guess that's all I can erase is this part. Let's see here. 5. 5 will squeeze into the right. Oops. Now 5, what we notice is we're actually going to FOIL out complex conjugates. And something's going to happen with complex conjugates that we like. So let's FOIL this out. Let's say we're going to have 3 times 3 is 9. So I'm going to squeeze this over. I apologize, it's getting a little sloppy. Then our outer terms, 3 times negative 2i is minus 6i. Our inner terms, 2i times 3 is plus 6i. And then the last terms, 2i times negative 2i is negative 4i squared. All right. Here's the good thing. When you FOIL out conjugates, and we did this before with radicals, the middle terms always cancel out. So those i's go away, and we have 9. Now remember, this is minus 4i squared. This is like saying minus 4. I squared is negative 1. Well, you really just change the sign, and it's 9 plus 4, which gives us 13. So we like this. When we FOIL out complex conjugates, we're always going to end up with a real number. The middle terms, like these middle terms, they're always going to go away. All right. Okay, let's see if I can squeeze this in here. Complex conjugates. I'm going to put this in here. Let's say we have a plus bi times the quantity of a minus bi. If we FOIL this out, what's going to wind up happening, the i's are going to cancel out, and we're just going to get a squared plus b squared. Always, in every case. And if we look back to number 5, okay, look, a in this case was 3. If you square the 3, you get 9. B in this case is 2. If you square that, you get 4, which is this right there. And if you don't remember, you can FOIL it out, but you're going to get the same thing. All right, so what I'll do is probably for number 6, I'll FOIL it out, and then I'll use this little trick, this little formula right here. All right. Okay, let's do this. Okay, number 6, I'm going to FOIL it out first just to show you again. All right, so 1 times 1 is 1. Outer terms, 1 times negative I is negative I. Inner terms, I times 1 is positive I. So those cancel out. And then I times negative I is minus I squared. So these i's go away. So then you just have 1 minus, well, I squared is negative 1. 1 minus negative 1 is just 1 plus 1, which is 2. Here was the shortcut, right? Here's the shortcut, a squared plus b squared. Well, in this case, a and b are both 1. So it's just like saying 1 squared plus 1 squared. That still gives us 2. Okay, 7, if I use the shortcut, these are conjugates. A is 4, so I just square it. And then I add b. B in this case is 3. So I just have 3 squared. Well, that's just going to give me 16 plus 9, and I just end up with 25. All right, now why are we doing this? Why are we emphasizing complex conjugates? If you go to the next page, this is why. All right, the next page, here you're going to see we have i's in the bottom. Now, remember when you had problems like, let's say you had this, 1 over the square root of 3. Remember how you would rationalize it? You would get rid of the square root. Well, technically, like you would multiply it by root 3 over root 3, and you would get root 3 over 3. Kind of the same concept here. I don't want to be left with this I in the bottom. So what we do, we multiply by conjugate to get rid of the i's. That's the whole point of complex conjugates. So I'm going to multiply the bottom by 4 plus 2i, and I have to multiply the top by the same thing, 4 plus 2i. Let's first take care of the bottom. This is the easy part, where I can use the trick. The a value is 4, so I have 4 squared. The b value is 2, so I have plus 2 squared. So this is going to give me what? 16 plus 4. I'm going to get 20 in the bottom. Real easy. Now, the top takes a little bit of work. I have to FOIL this out. So let's see here. 2 times that 4 is 8. 8. 2 times this 2i is plus 4i. 3i times this 4i is plus 12i. And 3i times 2i gives us plus 6i squared. Okay, and let's see here. If I add, I'm going to add these together. So we're going to have 4i plus 12i is 16i. And then this plus 6i squared just becomes minus 6. So really, this equals, I can combine the 8 minus the 6 is 2. So it's just 2 plus 16i over 20. And let's see here, 2 over 20 is 1/10. And then 16 over 20, that reduces to what? 4/5 I. So we'll put 4/5 I. All right, so that's the whole point of multiplying complex conjugates and FOILing them out. You get rid of i's in the bottom, so I just have a number in the bottom. I'm going to get rid of that square root. So it's kind of like rationalizing the denominator. Okay, when you come in tomorrow, I want you to do number 9, and I also want you to do, I think it was number 2 from the intro. We used the quadratic formula. But everything, the big thing, I is the square root of -1, and we're just kind of doing basic operations with complex numbers.